Hello everyone, I welcome you all to yet another video on geometry topic. So this is the sixth video in the series, right? So in the previous videos we have seen questions coming from the triangles, quadrilaterals, right? So in this particular session we shall be looking at questions coming from few other areas like polygons, for example. So this entire topic, this entire video will be majorly about polygons. So let's get started. So before we enter, there are few details I would like to share. So when I say polygon, so in a general polygon, we have the following: sum of interior angles in a polygon is always number of sides minus 2 times 180 degree always. Sum of exterior angles will be equal to 360 degree always. Number of diagonals in any general polygon is number of sides into n minus 3 upon 2. Now comes the next part. Generally in your competitive exams you won't be reading polygon alone, hexagon, octagon alone. You would also be seeing one more term attached to it, which is regular polygon. So what do we mean by regular polygon? So regular polygon basically means the polygon where all sides and all angles are equal. Such a polygon we call it as regular polygon. So in case of a regular polygon, what will be each exterior angle? So the overall sum of n different angles is 360. Each exterior angle will be 360 by n. Similarly, each interior angle will be nothing but this overall sum by n, or we may also write it as 180 degree minus 360 by n. You already know the exterior angles value, each exterior angle. 180 minus that will give you the each interior angle, because in a polygon, as you can see, the interior angle and the exterior angle, they form a linear pair. So this is the exterior, this is the interior, they form a linear pair. The sum is 180. And number of diagonals formula will be same. Alright. Now if I take a regular polygon, let's say n-sided polygon. So there is one vertex, second vertex, third vertex, fourth vertex, fifth vertex, sixth vertex, seventh, eighth, ninth, and so on, 10th and so on. So the polygon looks like this. So in this polygon, it's a regular polygon. So that would mean what? It would be having a center, and this center would be equidistant from all the vertices. So if I connect it to all the vertices, this will all be equal. It will be radius. By the way, it's called a circumradius, right, in this particular polygon. And if you also look at the center, point O, it will be equidistant from all the sides also. So that means if I connect this O with each side perpendicular distance, this will be the small r in radius. So these will be in radius, and this is going to be circumradius. So the ones that I draw right now are circumradius, right, both of them. In radius will be this. This is your in radius, small r. This is your small r. This is your capital R. Now there is a direct formula to find out small r and capital R, right, if you know the side length. I am directly sharing the formula. I am not getting into the derivation and part of it, right, because that is not really necessary as far as this video is concerned. So one of the formula is the length of in radius. So what is in radius equal to? So it is equal to a by 2 into cot 180 degree by n. So this is the formula. N is the number of sides, cot is the trigonometric ratio, and a is the side length of the regular polygon. Capital R is a by 2 into cosecant 180 by n. Now one more formula, area of the regular polygon will be equal to n into a square by 4 into cot 180 by n. So these are a few formulae that works for all the regular polygons, be it regular hexagon, be it decagon, be it octagon, right, any regular polygon. So these formulae works only for regular polygon, these also works only for regular polygon, this is for general polygon. Right. Now let's get started with the questions now. Let me clean this all. Please make a note of it. the very first question that we have is this. So it says a unit square is cut at all the vertices so as to form a regular octagon. So square is there, it is a unit square. So that means the side length is 1 unit. Okay, it is a unit square. Now we are cutting at all the vertices so as to form a regular octagon. So one can imagine we are cutting like this. So maybe we are cutting away this part here. We are cutting away this part here. So this part will go away. This part is gone and this part is gone. Now please visualize a diagram which is left after removing the cut portions. So we will be left with a polygon like this, right? It would be like this, and he says it is a regular octagon. It is given, it is a regular octagon, regular octagon. So now he is asking us what is the ratio of the sides of the octagon and that of the square. Square is 1, so we can ignore that. So we simply have to find out side of the octagon, because side of the square is 1. So in the ratio, when you write each to 1, that will vanish. Anything by 1 is the number itself. So we simply have to find the side of the octagon here, right? So let's see how do we do it. How can we do it? So this is the octagon that we have, right? So if I just try to replace the parts, so this is how the square would have been formed. This is how the square would have been formed. This is how the square would have been formed. Right? Let us assume this side length of the octagon is A. Let us say it's A. That means this is also A. Everywhere it's A. Now please look at the corner right angle triangle, this one. So in this right angle triangle, it's like this. This side length is A. And on account of symmetry, can I say, because whatever length is coming here, regular polygon is coming here, on account of symmetry, can I say this length out here, the cut portion, will be equal to this length here, the cut portion. Because if they are not equal, then you won't get the same side length here, right? It won't be A, it would be something else. It would become, let's say, A plus X or A plus some delta. So in order to keep it as A throughout, these lengths, the cut portions, this one and this one should be equal. So it should come exactly in the middle, something like this, of the square sheet. So if I take it as X and X, it's a right angle triangle here. So we can then apply Pythagoras. X square plus X square will be equal to A square. So X will be equal to A upon root 2. So this length here is A upon root 2. This will also be, on account of symmetry, A upon root 2. So that means what is the overall length of the side of the square? It's going to be A upon root 2 plus A upon root 2 plus A, that should be equal to 1 unit square. So when you simplify this, root 2 will go root 2 times. When I take A common, A into root 2 plus 1. So hence can I say the value of A, which is nothing but side of the octagon, is 1 by root 2 plus 1. And when you rationalize the denominator by multiplying and dividing by root 2 minus 1, you will get root 2 minus 1 in numerator by root 2 whole square 2 minus 1 square 1. 2 minus 1 will be 1. So finally the side of the octagon, regular octagon, will get as root 2 minus 1. That is what we are required to find out. Because once you get the side of the octagon, the ratio is going to be 1, which is nothing but root 2 minus 1. So this is a required ratio. We could solve it like this. I hope we are clear with this. Please make a note of this. Look at this. Now the next question is on hexagon. It says in a regular hexagon, what is the ratio of the longest diagonal to that of the shortest diagonal? Look at this. So if I try to draw the regular hexagon first, it would look like this, rough diagram. So let's say it is vertex A to F. And in this case, it's a regular hexagon. That means the center of this hexagon will be equidistant from its vertices also, from its sides also. So if I connect it to all the vertices, this is O, let's say, we shall get like this, right, and so on. And we can also connect it like this. Also notice one more thing, when you divide it like this, there are 6 triangles which are formed. 1, 2, 3, 4, 5, 6, 6 triangles. Overall angle at the center is 360 degree. So if you divide into 6 equal triangles, can I say each angle here is going to be 60 degree. So this angle is 60. Not just that, also notice that OA is equal to OB, because the center of the regular hexagon is equidistant from its vertices. So if OA is equal to OB, that means triangle OAB is isosceles. So 2 theta plus 60 should be 180, that means theta again will be 60 degree. So this theta here is going to be 60 degree. So that means this triangle OAB is an equilateral triangle. So the moment it's equilateral triangle, can I say if the side length is A, OA is also going to be A, OB is also going to be A, OC is also going to be A, everywhere it's going to be A. And please notice in this diagram, which one is going to be the longest diagonal here? So can I say longest diagonal here is going to be when you connect the extremely endpoints A with D, or E with B, or C with F. In each case, please notice what is the length. So can I say longest diagonal is nothing but equal to A and A, which is 2A. So longest diagonal is 2A, simply A units and A units. Also let us look at, I will just clean this all. Let us look at what will be the length of the shortest diagonal. So if you want to find the shortest diagonal, how do we get there? So AB is the side length. Let us go for the next vertex, AC. AC is going to be shortest diagonal, or BD is going to be shortest. So basically alternate vertices. Just skip one vertex, move to the next, or CE, or DF, or EA. All these are shortest diagonals. So what is this length going to be? Please notice again. We know that each interior angle in a regular hexagon, by the way, each exterior angle is how much? 360 by 660. So each interior angle will be 120 degree. This is side length A, this is also A. So that means triangle ABC is isosceles. So these two will be equal, 30 degree each. So either you can use the cosine rule here to find AC, or there is a property that we have. The property is, if angles are in the ratio 1:1:4, that means 30 degree, 30 degree and 120 degree, the one that we have here. Then the ratio of the corresponding opposite sides will be 1:1:√3. So that means 30 degree opposite is 1 part A units, 30 degree opposite is 1 part A units. So 120 degree opposite will be √3 parts, which is A√3. Either use the cosine rule, or you can make use of this particular property, ratio between the angles and corresponding ratio between the sides. So the shortest diagonal is going to be A√3, like this. So he is asking us for the ratio of these two, and hence can I say my answer is nothing but A will cancel out, 2:√3. Alright, I hope it's clear. You may note this down, and this particular point. Now there are such similar relations that we have, which I am sure you are aware of. If angles are in the ratio 1:2:3, that means the angles are 30 degree, 60 degree, 90 degree. Then the corresponding opposite sides will be 1:√3:2. Similarly, there is one more. If you can note this, similarly there is one more. If the ratio of the angles is 1:1:2, that means 45 degree, 90 degree, then the ratio of corresponding opposite sides will be 1:1:√2. So these are the three different properties that we have. So when the angles are 30, 30, 120, this is the ratio of sides. When the angles are 30, 60, 90, the ratio of the sides is 1:√3:2, and when the angles are 45, 45, 90, this is the ratio of sides. I hope this is clear. You can just note it down. Next, consider a regular octagon. So by the way, in case you are not able to see the octagon, octagon is here. I will just highlight it in red color. This is the octagon, regular octagon, okay, the one in red. with side length of 6, side length is given to us, with circumcircle and encircle. So there are two circles also, if you will see, I will just highlight them also. With blue I am highlighting the circumcircle, roughly it is like this, okay, blue, and with green I am highlighting the encircle. Please notice. So diagram is not very legible, not very clearly visible. So it is like this. I hope it is visible now. Blue is the outer circle, green is the inner circle, red is the octagon itself, regular octagon itself. Next, what is he asking us? What is the area of the region in between the two circles? So if you look at it, there is this region in between. I am trying to highlight it in black now. Please notice this in between region. We have to find this area. So it is very simple to understand that that region will be nothing but area of circumcircle minus area of encircle. I hope this is clearly visible here, right? That is how we will calculate it. Now what is area of circumcircle? It is nothing but pi into circumradius square, pi r square, minus pi into in radius square, pi is common. Now what is circumradius in case of a regular polygon? I will just help you recall the formula. It was a by 2 into cosecant 180 by n. This was the circumradius. In radius a by 2 into cot 180 by n. N is 8 over here, it is an octagon, it is 8. So what will be capital R? It will be a by 2. A by 2 is side length is 6 by 2 into cosecant 180 by 8, sorry, minus, it is square of this, it is square of this, square of this value, minus small r square will be a by 2 again, 6 by 2 into cot 180 by 8, square of this. So pi into this is 3 square will come out, we can take it out 9, into cosecant square 180 by 8 minus cot square 180 by 8. And we know for any value of theta, cosecant square theta minus cot square theta is always 1. That is a identity, trigonometric identity that we have. So this becomes 1. So thus my answer will become 9 into pi. This is nothing but 9 into pi. So this is how we can get to the answer if you know this formula. If you do not know this formula, deriving it in the exam, it is not so easy, not so convenient, right? Not possible, right? So if you know the formula, we could do it in like around 2 minutes, this question, or maybe less depending on our speed. But if you do not know the formula, then it is almost impossible to get to the answer. However, I would like to share one more formula here. Now, he is asking us what is the area in between the two circles. There is a direct formula for such questions. It is nothing but pi a square by 4, that is it. A is the side length. Area in between the two circles is always this. A is 6 in this case. So pi into 6 square, 36. 36 pi by 4 is 9 pi. Directly we will get to the answer. So instead of 2 minutes, I can get my answer in maybe 10 seconds. So this is one more formula that I would like you to make a note of. Alright. Let me clean this. Okay. So with that, we have come to the end of the session today. Thank you and all the very best.